Hey, what's good, ladies and germs? Today we're going to be talking about average rate of change, and this is something that hopefully you have seen before, but again, if I expected you to remember it, I wouldn't teach it. So all we're going to do today is we are going to learn how to calculate the average rate of change. Most people call it rate of change, but I hate lying to you. We're finding an average. If you want the actual rate of change, you need calculus. Calculus? Yeah, I spelled that right. Spell check. So we're finding an average. Don't let that freak you out. It's the easier way. All right. So let's start with our definition or our formula. They're the same thing depending on how you look at it. So an average rate of change is the average change in y per change in x, or for a change of 1 in x. What that means is if I go to the right 1, how far up or down do I go? Okay, that's really what we're asking, is every time I move over 1, what's the change? Okay. I'm sure you guys are familiar with a lot of this formula stuff down here. You are probably most familiar with this one, because this is what we teach Algebra 1 and Algebra 2 students. But because you're going to be going to college soon, let's talk about just a couple different ways to write it so that if you see them later, you don't freak out. This is how I like to write it because it's the smallest and I don't like to write too much. This triangle thing here, this is the Greek letter delta. And delta is usually used in math to represent change in something, right? So in this case, it's the change in y. In this case, it's the change in x. This is the formula you've always used. One thing I want to point out, you can tell that you have your formula set up correctly if your y's are on top, of course, but a lot of times students will either switch the top or switch the bottom. So when you are plugging in ordered pairs, the ordered pairs should always stack up. The 2's should be over each other, and the 1's should be over each other. So as long as your ordered pairs are stacked vertically, and you could draw circles around your ordered pair, you know you've got it set up correctly. If you do switch these, the only thing that's going to happen is you're going to get a sign error. So let's say the actual answer is 3. If you do this switching, you're going to get an answer of -3. Okay. This is more how scientists say it, your final minus your initial, because they measure changes in things. It's just a more sciencey way to explain it. Okay. So whichever one is your favorite, this is the one you're probably most familiar with. They all mean the exact same thing, though. All right. Let's start by looking at an example, because this is really straightforward, and I think most of you have seen it before. So the first thing we're going to do is we're going to figure out what are the ordered pairs for A and B, like what are the numbers for them, and then we will arbitrarily assign one the designation of 0.1 and the other one 0.2. Just pick so that you're consistent when you're plugging stuff into this formula. All right, so I'll call A 1 and B 2. It doesn't matter. We could call them A and B. And A's ordered pair is at 2, 3. And B's ordered pair is at 4, 1. Okay. So we are going to find our average rate of change by plugging this into our formula m equals y2 minus y1 over x2 minus x1. So 0.1 is A. That means its y is y1 and its x is x1. So we're going to plug those in here and here. When we do that, it looks like minus y1. So I'm going to put the negative sign because this is part of the formula. It doesn't matter if this is positive or negative. We should always have a minus here. y1 is 3. So I plug in the 3. Same thing on the bottom. The minus is part of the formula, so we should always have a minus here. And x1 is positive 2, so we plug in the positive 2. Now we can go plug in y2 and x2 right here. Y goes on top. There's nothing in front of it, so we just fill in the number. Same thing with the x2 on the bottom, 4. Now we can see 1 and 4 are vertically stacked, and 2 and 3 are vertically stacked. What that means is that we have it set up correctly, and we should get the right sign. So when we do this, 1 minus 3 is negative 2, and 4 minus 2 is positive 2, and then of course reduce this. So the average rate of change between these 2 points is negative 1. What that means is this line that I drew straight between the 2 points, it means the slope of this line is negative 1. All right, so that's how you would do it if you have 2 points on a graph, or if I just give you the 2 ordered pairs. We plug them into the formula, make sure stuff is stacked up so we get the right sign, and then simplify. All right, what if I don't give you a graph or a formula though? What if I just give you a function? So let's talk about that really quickly. It says, given that f of x equals 3x minus 2, find the average rate of change from f of 2 to f of 6. So f of x, this is giving us a hint to the numbers over here. This 2 and 6 are our x values. Okay. So we already know parts of our ordered pair. We know it's going to be 2 and something, and 6 and something else. The way we get our y values is by plugging the x's into our function and evaluating. So let's do x equals 2 first. F of 2 equals 3 times 2, plugging in 2 for our x, minus 2. So 3 times 2 is 6, minus 2 is 4. So our first ordered pair is 2, 4. Then we repeat the process with 6. So f of 6 equals 3 times 6 minus 2. 3 times 6 is 18, minus 2 is 16. Now that we have our 2 points, we just want to label them either A and B or 1 and 2. So I'll say this one is point 1, this one is point 2. And then we're going to fill in these ordered pairs into our formula for the average rate of change. Okay, so plugging in, I'll start with point 2. So the y value is 16, minus, because the minus is part of the formula, something, over x2 is 6. Put your minus sign because it's part of the formula. Then we fill in y1 and x1. So we look here, y is 4 and x is 2. Now we just simplify our fraction. 16 minus 4 is 12, and 6 minus 2 is 4, and 12 divided by 4 is 3. So our average rate of change is 3. All right. Those are just a little bit of background, easy problems to get you warmed up. On your homework, you're going to see mostly application problems. The only thing I saw were application problems, but there might be 1 or 2 with a graph on there. So there's a lot to break down here. Let's start with the context. We're going to ignore math for a second. I'm just going to tell you a cool story about bicycles. So in cycling, there's a challenge called Everesting. And what they mean by that is Mount Everest, right? There's a little flag. This is where a person rides their bike up and down the same hill over and over until they climb 29,029 feet. This is the height of Mount Everest. So you go to like your favorite park, you get on your bicycle. What do bicycles look like? There's a seat, there's a post. I think there's a wheel back there. I think there's some more bicycle up here. Right? Oh, you should have arms. So you go to your favorite park and you ride up this hill. This hill, let's say, is, I don't know, 30 feet tall. You're going to go up this hill and then turn around and come back down. That's 30 feet. Then you're going to do it again and come back down. That's 60 feet. Then 90, then 120, and so on until you get to 29,029 feet, which is the height of Mount Everest again. So this is some stupid challenge that people on bikes thought up of just to prove that they're the best at bikes or something. And this world record was actually just broken not that long ago, unless you're watching this video in the future, and in which case maybe that long ago. But in June 2020, this guy, I can't say his name, Lachlan, I don't know, it's some English name. I'm sure he's a great cyclist. Mr. Morton set the world record. It took him 7 hours, 29 minutes, and 57 seconds. So he basically just rode up and down a hill at his park for 7.5 hours straight. And that's what he did. And he set a world record. So what we're going to do is we're going to find his average rate of change in height measured in feet per hour. And we want to simplify this a little bit because I don't want to do the unit conversion to turn this thing into hours. So we're going to round to 7.5 hours. If he took 3 more seconds, it would be exact. 3 seconds compared to 7 hours is so small, it probably won't matter. All right. So now let's start our math problem. Okay. We need to start by figuring out some ordered pairs. Okay. The two things that we want to know about are feet and hours. Okay. So let's maybe think about the feet first. When you start a race or a hill climb, how far into the race are you? If you're at the starting line right now, how far from the starting line would you be? Right, here's your starting line. It's checkered, right, or something. Here's you. You're standing on the line. How far are you from this line? 0 feet away. So that's our first feet point. Let's go ahead and make feet. We'll talk about how you tell if it's X or Y in a sec, but it's going to be Y. So at the start, he's at 0 feet high. And how long has he been running if he hasn't started yet? 0 hours. So our first ordered pair that we're going to use is 0, 0. At 0 hours, he has gone 0 feet. All right. Now, I'm sure you can probably guess what the next ordered pair is. This is going to be our ending point. So when Mr. Morton finished his Everesting attempt, he had taken 7.5 hours, and he had climbed 29,029 feet. So here is our initial, and here is our final. Okay. Now I said we were going to talk about how we know hours is X and feet is Y. It comes from this hint right here. We want to measure it in feet per hour. So when we say feet per hour, the word per here has a very specific meaning. Hang on, I'm trying to erase this to make it easier for you to read. The word per means over in math, or it means slash, or however you like to say it. It means put a division bar there. So feet is on top of this division bar, and hour is on the bottom. If we think about our formula, m equals change in y over change in x, because the feet's on top here, and the y is on top here, that means they go together. So that tells me that feet, or height, has to be my y. Okay. Same thing, because hour is after the word per, or after the slash, means it's on the bottom of the fraction, and that's our x. All right. Once you've gotten this far, once you've deconstructed the problem and found 2 ordered pairs, it's not a word problem anymore. Now we're just plugging in numbers to a formula. So let's go ahead and do that. So m equals, let's see, y, feet came before per. Feet goes on top. So final, he ended at 29,029 feet, minus his initial, 0, over hours on the bottom. His final time was 7.5, minus his starting time of 0. So now this simplifies pretty easy. 29,029 over 7.5. And because we have a decimal here, let's just go ahead and plug into our calculator and get a decimal. So when we do that, whoops, excuse me, I forgot to turn on my calculator. Pretend I'm writing here. You guys could draw or something while you wait. So we have 29,029 divided by 7.5, and we get 3,870.53, and just the 3 repeats. Because you're in honors, you need to make sure you put units on this. So this is going to be in feet per second. And it tells you, right, or I'm sorry, not per second, excuse me, I'm doing physics. Feet per hour. Make sure it matches with what the problem tells you. All right, if you need help, go ahead and do the usual stuff. Maybe find another YouTube video. Go watch Khan Academy. He probably explained it better than me.